The Sputnik that the Russians launched changed the whole aspect of America's space attempts.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
Everybody changed gears at that point. The entire nation was now geared to make the Kennedy statement a truth. The Apollo program was set up as an endgame thing to get men on the moon and return them safely. But to get there, you have to learn to walk before you can run. And the preliminary things involved in doing that were projects that brought the experience up a level each time. And so the steps were taken one at a time. NASA would release these requests for proposals. All of the major aerospace companies of the United States would jump and would then issue their proposals, and that started an intense competition among the major aerospace contractors in the United States.
NASA never built anything. You know, we build small satellites and stuff like that, but we have always worked with industry, and we've bought the product from them, and then we owned it and operated.
And Grumman was not one of the big players, but the competition for the lunar program ended with the last contract to be awarded, and that was for the spacecraft, the Lunar Excursion Module.
Because it used to be LEM, which was Lunar Excursion Module. The command module was CM, service module was SM, so they made the Lunar Module LM. So they dropped the E.
And the task was to bring 2 men onto the surface of the moon, allow them to climb out, wander around, steal some rocks, and then come back home with their package of goodies.
You start out with a gigantic 6.5 million pound rocket, and you come home with about 30,000 plus pounds in one capsule that will splash down in the Pacific Ocean. Between those two events, you had dozens of events that had to take place and had to be successful in order for the mission not to be aborted each time.
We were developing technology that had never been used before.
The programs at the Cape, which only a few years ago were science fiction, are today becoming science fact.
The proposal was a nightmare. It was a 2-month effort from July to Labor Day 1962. After several reports during the months preceding, the proposal request was issued by NASA. They had specific questions they wanted answered. They said 50 pages, no more. 10-point type, no less. And so we had to have all these restrictions in addition to the words that are going to explain how it is that we're going to build this spacecraft. And a day before Election Day 62, President Johnson announced that the winning proposal for the last jewel in the crown, as far as I was concerned, was Grumman Aerospace Corporation. We won the proposal, we did it. So that was the onset of Grumman's odyssey.
No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space.
I was one person in a group of 20 that was selected to do the study, to come up with all the concepts and whatever we could for the LEM.
It really was an iconic engineering feat. Nobody had ever built a spacecraft that would pilot a man to the moon. And they had to throw out what they knew about designing aircraft.
They were certainly hand-built. There was nothing about it that was productionized. You couldn't say, you know, we had 10 of these or 10 of anything that you're looking at behind me.
We don't have enough information on outer space. Communication, you know, all the environment up there. The lunar surface is the temperature vary from roughly from 250 to -50.
every part on that LEM had to be checked. The idea was that while this LEM was sitting inside the Saturn V rocket and it had to withstand 10 Gs of force, we wanted to make sure that during its liftoff, nothing would break.
There were things I was worried about. Everybody thought the landing was the thing. I was concerned about lifting off the lunar surface to get back into lunar orbit to mate with the command module, because the sequence of events that had to happen perfectly were considerable. The two stages were connected by a few cables for batteries and stuff. They had to be severed with a guillotine. And if one cable didn't sever, that thing probably wouldn't have been able to get off the surface of the moon. There was zero tolerances forever. Everything had to be perfect.
We have done everything we can from step by step. So we were confident. So we were able to say, go for the Apollo 11.
At this time, I'd like to introduce the astronaut crew for the Apollo 11 mission.
Very many Americans across the nation have dedicated themselves to quality, craftsmanship, and ingenuity. I'm sure this American ingenuity and American craftsmanship has given us the best equipment.
6, 5, 4, 3, 2, 1, 0. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
That feeling of seeing Armstrong put his foot on the ground and knowing exactly how he did it. I mean, he came down the ladder. I knew what he was going to do next.
I'm going to step off the LEM now. That's one small step for man, one giant leap for mankind.
I mean, I worked there, my brains were off. It was incredible. And when I saw that LEM land on that moon, nothing could beat that.
I was with my family, my mother and father, brother, and I was on my knees in front of a General Electric black and white television. I have a professional engineering license in the mechanical branch as a result of the moon landing. And now I'm the CEO of the Planetary Society, and it exists to advance space science and exploration and to connect people with space. And the reason all that happened is largely connected with the moon landing.
Working on the smallest of parts and then seeing it together was outrageous. It's absolutely phenomenal to be part of this group.
You had dozens of events that had to take place and had to be successful, and consider the fact that on the end of this whole program, only one mission had a major malfunction.
I say God was on our side because everything that we did worked perfectly. And it went beyond expectations because we saved the crew on the Apollo 13.
Houston, we've had a problem. Stand by 13, we're looking at it.
And that was a real unusual situation, and yet the astronauts were brought back home by the success of the lunar module itself.
I developed a fondness and respect for engineers, because up until then I really never knew any engineers. They would ask us, do we think that they could design these parts better? Something that we might know because we actually handled the material. It was totally different.
Grumman was very adept at nurturing its employees, especially its summer employees. That was just a marvelous thing for me.
Living on Long Island and working on Long Island at Grumman was a gift. The benefit of the co-op experience, you're able to see many other departments throughout a 5-year period. The co-op experience at Grumman laid the groundwork for me getting all those other jobs.
Prior to just 72, we had gotten word, the engineering group that I was in, we had gotten word that it was over. There's no more LEMs. And I'll tell you, that was a sad day. It was a tough deal.
It demonstrated that given a goal that the population could understand and embrace, that we could do practically anything that we wanted technologically. We just needed to put our minds to it.
I didn't think of it as being special or anything like that. My task was to get the job done correctly, and that was the way I worked all my life. It was an important piece of history, but it was my job, and my task was to do the best I could.
Well, all the knowledge that we have developed, the structural area, electronic area, the cell phone you have, that's the commercialized of space technology. And I feel very happy that I have done part of it.
We discovered the age of the Earth. We learned more about celestial mechanics. Halo orbits were developed as a result, but it was really an engineering effort to outpace a competitor.
For an engineer, the legacy to me was sending men into space. The human experience about adventure is always going to be there, and the space program talked about an adventure.
It was the first of a series of Apollo flights that captured the interest of our citizens, and I think it opened the door to further exploration of space.
The NASA budget was 10 times what it is today, and it just shows you when you throw money at the problem, you can accomplish great things.
The Apollo 11 mission and the first lunar landing laid the groundwork for the exploration that we're doing today. It demonstrated that humanity can, in fact, leave this planet, go to another place in our solar system, and live there for some period of time. We're just trying to expand that period of time.
I think it's really important to go back to the moon and beyond. Even though we've already been there, it's really inspiring that next generation of going back to the moon, but then it's also setting up that infrastructure for us to assemble the spacecraft that we're going to need to go out to Mars.
This industry, the aerospace industry, has been built around and has grown up throwing out these marvelous machines. So what we're headed for, what we're trying to achieve, is rapid and complete reusability. And again, that's important because you can't get people to Mars and back unless it's reusable.
Landing zone, side boosters have landed.
2024, 2028, sometime between then, we're going to find that we're no longer even in the space station era. We're now into the era of exploration, of human and robotic exploration far beyond low Earth orbit. But using robotic capabilities, we're going to be able to virtually explore worlds that much beyond our belief, worlds that only science fiction writers dared venture into before. I mean, real live engineers and scientists are going to be living and working in these worlds, even though it's virtually, because of the satellites and the instruments and the robotic explorers that we're going to have.